Hey everybody, this is Larry. This is the last day of the year. Yay! Day 31st, and I have to log in again because I changed countries. I feel like the Leetcode has always been. I don't know, every time I change a country, I have to log in again. I forget because, well, I don't know. I just log in. And I think it's because of the account sharing or something, but still, it's really annoying for me. But in any case, let's refresh. I am obviously maybe back in New York. I just got off the flight and got back. Haven't even taken a shower yet, so I want to do that. But yeah. So today no intro, but I'll probably be doing some what you would call it retro intro. So it'll be fun. Uh, I have a lot of interesting things to share. Maybe not. I don't know. But yeah, but I am excited to finally get some rest because when I travel, I go a little bit hard. Okay. I also have a sore throat, so let me know in the comments what you know if the thing is good or bad, or I don't know what I'm talking about anymore. Okay, I need a rest, but it's already 10 a.m. here in New York, so kind of late on this one. So let's get it for the last day of the year. Today we have 1970. Also, if you're watching this or if you're in a place where it is already New Year's, well, obviously, Happy New Year, everybody. Let's end this year strong and or start the year strong. So let's go. 1970, last day where you can still cross. Okay, you have a one-based binary matrix where 0 represents land, 1 represents water. You're given an integer of rows and columns represent the number of rows and columns in matrix respectively. You have 0 and time matrix is land. However, each day a new cell gets flooded with water. Okay. Yeah, I mean, it seems like my first intuition when you see something like this is that it's gonna be binary search. Might not be, but it's probably a fun idea, right? That this one may be a little bit tricky, but probably still possible because when you say stuff like last day where you can already cross or you can still cross, that means that there's going to be a monotonic or monotonicity to it, right? Because it suggests that past a certain point you can no longer cross, but before that you can cross, right? So yeah. Okay. So let's take a look at the constraints. We have 10 to the 4th. I feel like that still should be good enough because that's what. Because if you do a connectivity thing, right, it's going to be on O of n times log n, right? Because we're binary search on the days or whatever. Is that gonna be good enough? 20,000. What is log of 20,000? Like 16 or something? 17. So it'll probably be fast enough. So that's one way. The other way, of course, is just using union find because, well, if the input is big enough that you have to do it one at a time, or you don't have to, but you do it one at a time anyway, then you could use union find because you're just going to incrementally do it, and then just find first day where that's not true, right? Yeah, and I'm gonna do a union find version because I feel like that's just maybe just a little bit less error prone. I am not going to go over union find in this video, so definitely check out those videos when you have to. But yeah, so the way that I always write it is something like this. Oh, it's so nice to it's so nice to type on a keyboard for the first time in weeks, or like a a physical keyboard versus the laptop keyboard. So yeah. Also, my nose is congested, so I'm talking funny. I don't know. It is what it is, but let me know, I suppose. Yeah. And what I'm writing is kind of straightforward for union find, but like I said, I'm breaking new grounds here. Here's path compression. I just do pick a I just union however I like. So yeah. I realized I didn't describe without how to do this, did I? I just kind of union find into it. The idea is that you're trying to get I guess I have to kind of explain this part a little bit. So you're trying to get from top to bottom, and of course the binary search method, that's pretty straightforward, right? You know, you just kind of do a BFS or depth first search, whichever you like. But for the union find solution, another way to think about it is that there is a line from left to right of water, right? And when that happens, that means that you cannot cross it, because it seems like you cannot go diagonal. But that means that the water can go diagonal, and if there's a line from left to right, or right to left if you would prefer, of water, then that's when you know it's not possible. That's basically the story. And that's all I need. Right. So I would just, yeah. Actually, maybe I'll do this. Right. Why is my keyboard wrong? Huh. I think I have to. Huh. Is something something is not running on my computer, I think. I think okay, so that's why. Okay, whatever then. I'll fix it later. Left is equal to, right. Alright, what I'm doing is that I create one union find node for every cell, obviously, plus two. One for the left and one for the right. And then now we can, you know, just in the beginning. No, actually, it doesn't make sense. Never mind. Yeah, and then now we just go for X, Y in cells. Yeah. How do I want to write this? I mean, we have to keep track of the water, right? So maybe we have like. And you can say that the two waters, one is the left and one is the right, right? And then now we just have to, yeah, water x times plus, right? And then now we just look at the 8 directions, whether we get connected, right? So for example, right, for I'll write it another way. Why am I so bad today? This way always looks a little bit funky. Right, then now if water of x plus d, well, so basically, if it is the water and the neighbor is water, then we then yeah, we union them, right? I feel like I need a helper for this. For like converting this, but for now, I don't know. I'm just so tired. Okay, right, and then now we check. We actually need to enumerate this so that we get an index, right? But yeah, it's if the union find of left is equal to union find of right, that means that they're connected, then we can return D, right? Else we just return D at some point. I mean, it'll be way before that because of pigeonhole, right? But it's fine. Yeah, but the only thing that I have to change a little bit is also if y is equal to 0, then we union them with left, right? And if y is equal to car minus 1, then something like that. Hopefully that's right. Is this one indexed? Oh, it is one indexed. Okay, that's fine. I just kind of didn't pay attention. I remember reading in the problem now, but I'm just okay. Looks okay. Let's go a quick submit. Hopefully no silly mistakes. We got it right on the first go, which always makes me happy. Where's the pop-up? Don't I have a pop-up? Let me refresh real quick. Okay, my streak. I guess just no pop-up. But yeah, union fine, right? Each, each union find operation takes a say O of 1. You can make it more optimization if you want. So this is all going to be O of 1, right? This is only at most 8 union things. And yeah, that's all I have with this one. Let me know what you think. Thanks for watching. It's a little bit terse today. I think I got a little bit sick on the way back, but we'll try to figure things out. But yeah, thanks for watching, everybody. Stay good, stay healthy, good mental health. I'll see y'all later and take care. Bye bye.